Good afternoon. We are going over or reviewing area, surface area, and volume. You need to make sure that you have a calculator and your formula sheet as we proceed through the review for the class. This is Unit 10. Question number 1. It asks you to find the area of the shaded region. So to find the area of my shaded region, I first need to make a plan. My plan is going to tell me that first I need to find the area of the rectangle. And from that, I'm going to need to then subtract the area of the big circle and then the area of the small circle. So I need to find those 3 bits of information before I get started. So first, to find the area of my rectangle. The area of a rectangle is length times width. With that, I'm going to need a length and a width of my figure. Well, I know here that my length is going to be encompassed by the diameter of the first circle plus the diameter of the second circle. So my length here is going to be 30 across. I know that my big circle touches both sides of my rectangle. I know its diameter is 20 this way, so it has to be 20 this way, so my width is 20. So now to find the area of my rectangle, it's going to equal length times width. So it's going to be 20 times 30. So it's going to end up being 600, whatever the units are, squared. Okay, the area of the circle, let's make my large circle, is going to equal pi r squared. So of my large circle right here, I'm going to need a radius. A radius is half of my diameter, so my radius is 10. So it's 2 times, so it's going to be squaring the radius. The radius is 2 times the diameter. Does not matter whether you use pi or whether you use 3.14. I typically use 3.14. So I get 314 squared, whatever it is. Now I'm going to have the area of my small circle. It's still area is pi r squared. But now my small circle, the diameter is 10, so my radius is 5. And just as an FYI, the only thing being squared is the 5. Then I'm multiplying that answer by 314. So now I'm going to take my total area of the whole thing. I'm going to subtract out the large circle. Then I'm going to subtract out my small circle. So 207.5 units squared is the total area of my shaded region. Because I subtracted out the 2 circles out of the area of my rectangle. Number 2 says, find the radius of circle L. Here I have some sector stuff going on. So I can use, I have the length of my arc being 10, and I have my measure of my arc being 110. So I can use the formula that says arc measure over total measure of my circle equals arc length over 2 pi r because it's a piece of the circumference that we're trying to find. So when I use this proportion, I then know that my arc measure is the same as my central angle. My arc length is given as 10, and now I'm trying to find r. Since it is a proportion, I just need to cross multiply and then divide. So 110 times 2 pi r equals 360 times 10. 110 times 2 times 3.14, 690.8 r equals 3,600. Divide by, was it 690.8? Oops, sorry. And I end up getting my radius to be 5.2113, blah, 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 blah. So I'm going to round it to about 5.21. And because it's meters, a radius is still meters. For my final answer. Again, because I'm given the unit circle, I know it's going to have to be the arc measure over 360, and because I'm giving arc length, it's the arc length over the circumference of the circle. Number 3, the area of the circle C is 120 meters squared. Find the indicated measure below. Well, we know that circumference equals pi times diameter, or circumference equals 2 pi r. Both of those are on my formula sheet. So here, I'm given the area of my circle is 120. So sorry, that's my circumference formula for my circumference. Sorry. We know that area equals pi r squared. Sorry, so I had to start there. I apologize. Area equals pi r squared. So now I know that my area is 120. I'm looking for my radius. So I'm just going to divide both sides by pi. So 120 divided by 3.14. That's 38.216665. I'm not going to take that out of my calculator. I'm just going to recall the answer. Because I have the r squared, I'm going to take the square root of the answer that's in my calculator, and I find my r to be 6.18 rounded, so it's about. And we know because it's my radius, it's going to be meters. Now I can apply it to this formula here, that circumference equals 2 pi r. So circumference equals 2 times pi times my rounded answer. Or I can just leave it in my calculator because it's still sitting there. So times 3.14 times 2. So my circumference is 38.82 about. Again, it is rounded meters. Circumference is meters because it's perimeter around a circle. I'm going to find the surface area of this solid. This solid is a cylinder, so I'm going to look on my formula sheet, and it says that surface area equals 2 pi r squared plus 2 pi r h. So I need to make sure that I have an r and I have an h. So here it comes halfway across. R is my radius, so it comes halfway across, so that is my radius. H is my height. It's how tall my cylinder is, which is 12. So I have all the necessary unknowns. You need to remember that because it's addition, I need to solve each segment. And then I need to add my two segments together. Those of you who are trying to do it as one big happy thing, you're getting things wrong. And then I add both segments together. Because it's area, I have centimeters squared. Okay, I have a surface area of this solid. This solid is a sphere. So again, looking on my formula sheet, it tells me that surface area equals 4 pi r squared. Here, my unknown is a radius. They gave me a radius because it's halfway across. So surface area, 4 pi 21 squared. So I have a big number as my answer when I put it all into my calculator. And again, because it's area, it's squared units. Number 6, I'm trying to find the volume of the solid. Now, with this, I'm going to make a plan. I have a sphere, and I'm adding to it a cone. What's nice about volume is volume I can just add the two pieces together, because remember, volume is what fills up my figure. So it's talking that this whole cone here at the bottom is filled up, and this whole snow cone piece is solid on the top. So how much volume do I have here? Which is nice, because when I have surface area, I got to worry about overlap. Here, I don't have to worry about the overlap. It's solid and it's solid. So my sphere for volume, my sphere formula for volume is the weird one. It says 4/3 pi r cubed. It's volume. Plus my cone volume. So for my cone says that volume equals 1/3 pi r squared h. So looking first at my sphere, I need to make sure I have a radius. So looking at my sphere, I have a radius right here of 3. So I have 4/3 pi 3 cubed. Okay, looking here at my cone, I need to have a radius and I need to have a height. A height is an inside height. So here I have 2 for my radius and 5 is my height. So I have 1/3 pi r squared times my height. Again, I need to do each segment. Remember, you can use the caret button. Just putting this out here for a second. The caret button is right here to do a cube, or under my math button, I can do a cubed right there at number 3. Either way works. The caret button to me is a little easier, so I tend to use the caret button. When I'm working this, I can put it into the calculator at one time. I just got to be careful of my fraction. Not sure if you get the same answer or not, but whenever I have a fraction, I put it in a parenthesis inside my calculator. Unless it's like 1/2, I'll just divide the whole thing by 2. But here, when I put it into my calculator, I do 4 divided by 3, and a parenthesis, times my pi, 3.14, times 3 raised to the 3rd power. You should get that as your answer. Now when I come to work to this side, I can either do 1 divided by 3 again in a parenthesis like we did the last one, or I can do divide the whole answer by 3. It just depends on how you look at it. And the 3 is going to repeat forever. I'm just going to take it out to there. Add it now to my 113, and I get 133.97, and because it's volume, it's cubed answers. Those of you who are trying to put it on the calculator at one time and not show your work, remember the last quiz. You didn't have the work that corresponded. I couldn't follow your work that corresponded to your answer. your answer didn't matter. You have to have the work that corresponds to your answer, and you need to show your work. Otherwise, you will not get credit for a bunch of answers. Okay, ugly guy, that's okay. I want the surface area of this solid. All right, so first of all, I need to make a plan. I have a pyramid. That's a square pyramid. I have here it's 16 by 16, so it's actually a cube, but I'm going to make it a rectangular prism because that's what it is on your paper. And I'm going to have to subtract my overlap. So now, when I subtract my overlap, what's going on? What's being overlapped? Remember when we were looking at this before? When I find the whole area of my perimeter, this bottom piece is underneath. When I find the whole surface area of my prism, this bottom, this top of it is underneath. We don't care about anything in here underneath. All we care is the outside stuff. So the overlap here is two, in this case, squares or two rectangles. There's two of them because there's one for the pyramid bottom and one for the top of the prism. If you are one of those people who can look at it and go ahead and just do the lateral of the pyramid plus the lateral of the prism and add a bottom, do that. That is fine. There is nothing wrong with that. You could actually do a whole prism and just the lateral of the whole pyramid and just do the lateral of the prism. All of those work. What you have to remember is that all the outside is done. I'm going to go with overlap because that works best for me. You can choose any method you want. So now, the surface area of my prism, my pyramid, says 1/2 LP plus B. The rectangular prism is long. He is actually going to be 2 length width plus 2 length height plus 2 width height minus 2 squares, and my 2 squares are just going to be length times width. They're a plane figure. So they're just a length times a width or a base times a height, or it could be side squared. All right, to be able to do my pyramid, there's a couple things I'm going to have to find. I need to find the area of my base, I need to find my lateral, and I need to find my perimeter of my base. Those are the three things in this formula. So first, what's the area of my base? The base is going to be a square, so it's 16 times 16. Sorry, squeezing that in there because I didn't give myself enough room. Sorry about that. So it's 256. The perimeter of my base is the side is 16, because if this is 16, this is 16 up here, and this is 16 up here. So my perimeter is 16 times 4, which is 64. Now comes Mr. Lateral. Mr. Lateral is the pain. The 6 meters is not the lateral. The lateral is the piece that is over here. He is my diagonal. That is my lateral height. So I need to find my lateral. How am I going to find my lateral? Exactly. It's my friend, Mr. Pythagoras, coming back to my party. The lateral is the Pythagorean theorem. So for here, I know that this base right here, from here to here, is going to be half of that because the triangle kind of comes down the center. So he is going to be 8. Sorry, this pen's, the tip is messing up. Sorry about that. So he's going to be 8 right here because he's half the whole length. I don't know what that lateral is, which is actually right here on the piece. No, he's not. I lied. He's going to be he's perpendicular on the outside, but he's the diagonal on the inside. So he's still going to be Pythagorean theorem. We know that he's 6, he's 8, and I'm looking for my lateral right there. So my lateral is actually going to be my lateral squared is my hypotenuse. 6 squared plus 8 squared is my two sides. So 6 squared plus 8 squared, so my lateral squared is going to be the square root of 100, which is 10. So my lateral is 10. I had to use the Pythagorean theorem to find the lateral. Because he is a right angle on the outside, but he is my diagonal on the inside. So my lateral is 10 that I just found over there. So now I'm just going to do length with height right here and just put all my little pieces here, and then I'll make the one big substitution in a second. So here I have my length for this, for my prism is going to be 16. My width is going to be 16. My height is not given, but we're going to go ahead and assume that he is, that should be given. We're going to assume that he is a cube, and so we'll make it 16. And then I'm going to subtract the base, which is just 16 times 16. All right, that's my length and my width of that. All right, let's plug all this mess in and then add it all together. So first I have my pyramid. So 1/2 times 10 times 64 plus the area of my base is 256. I'm adding to it my prism, my rectangular prism. So it's 2 times 16 times 16 plus 2 times 16 times 16 plus 2 times 16 times 16. And from that, I'm subtracting out the 16 times 16 for the base of the pyramid. All right, so let's just get going on the calculator here. So I have 64 times 10 divided by 2. So I have 320 plus 256 plus 2 times 16 times 16. Need to use smaller numbers next time. So I have 512. They're all the same piece, so I can actually just add it 3 times. Minus 256. So now I'm just going to zip that whole big bad boy across my calculator. And I'll have 320 plus 256 plus 512 plus 512 plus 512 minus 256. So my final answer is 1856, and then again it's squared units. You will have something similar on your test. You'll have 2 that you're going to have to compositely put together for surface area and for volume, 2 composite figures. Sorry. Okay, number 8. Find the circumference of circle G. Because I'm finding the circumference, I'm then going to use my arc length over circumference formula. So I know that I have the arc measure over 360 is going to equal my arc length over my circumference. That is my circumference, that whole piece. So I can just call this x. The whole piece, the 2 pi r, is my circumference of my circle. Now, since this is the arc length, I need this arc measure to go with it because it's the central angle off the arc length, which means if this side is 250, then my arc length for the other side is 110 degrees. That's the piece I have to use because it has to be the arc measure, then the arc length to the piece, to the whole thing. So the arc measure over 360 equals my arc length over my circumference. Now it's just an easy mathematics. Oops, that's not right. Sorry, I hit a wrong button. Since I never identified my circumference being x, I want to go back and rewrite it here at the bottom that my circumference equals 127.64. All I did was cross multiply and divide. And I do know I'm going a little fast, so if I am going too fast, of course you can pause, or secondly, you can ask questions and bring them to class, or email me. That's fine. Okay, I want to find the area of the shaded region. So in this case right here, I want to find my area of my shaded region. Again, I'm going to make a plan. So my plan is that I have here, I'm going to call it a rectangle because I'm not sure at this point, minus another rectangle. All right, so I'm going to call it the large and the small. The large will be the outside, the small will be the inside rectangle. So first, because I want to make a plan, I know that area is length times width. So I'm going to have some length times some width minus some length times some width. So I need to do the large rectangle first. I know that he's 3, and I know that all of these match him, because they all have the 2 little lines on them. I know that he's 5, and I know that he's a right triangle right there. So to find the other piece, I can either say, hey, I remember my Pythagorean triplet, my 3, 4, 5, or B, actually use Mr. Pythagorean theorem to figure it out. But because I'm super savvy and I remember my triplet, I know that the 3, 4, 5 triangle goes together for a Pythagorean theorem. So now on my large rectangle, when I'm trying to find the length will be 7, and here my width will be 7 as well. On my small triangle, we know they're all 5 because of the congruence dash on each one of them. So I know that my length is 5, I know my width is 5. Now I just need to do each segment and subtract. Okay, for number 10, I need to find the volume of the solid. So first, I know it's a cone. So the volume of the cone, looking at my formula sheet, says 1/3 pi r squared h. So I need a radius and I need a height. The height's on the inside. So here I'm given a diameter. How do I know? Because the whole line is drawn. So my diameter equals 8. My radius is half of it. Here I know my inside height is 13.2, so he is my height. Once I plug everybody nicely into my formula, now I just need to do the math. Again, I'm using 3.14 as my pi button. And it's cubed centimeters. Last but not least, area of my rectangular polygon. With my rectangular polygon, we know, it's my regular polygon, sorry. I know that area equals 1/2 my apothem times the perimeter of my base. So I need to find an apothem. I need to find a perimeter of my base. Well, first of all, the perimeter of the base is the easiest. I know that this side is 3. I know it's regular, so every side matches. So that's 1, 2, 3, 4, 5, 6, 7, 8. So my perimeter is 24. The apothem gets a little difficult. The apothem, what is given here is a radius. How do I know that? Because the radius goes from the center to the vertice of the object. My apothem comes from the center to the side and forms my right angle. That is my apothem. When it does that, because everybody is regular and congruent, it bisects this side, so each piece is 1.5. So in here, to find my apothem, I can go ahead and have the Pythagoras show up to the party. When I go to find my apothem, it's either going to be Pythagorean theorem, or if I'm not given another side, I'll have to use a trig function with SOHCAHTOA. But here, I'm given the two sides, so I'm going to go ahead and do that. So I know that my apothem squared plus 1.5 squared is going to equal 3.92. Squared, sorry. My hypotenuse squared. So I have 3.92 squared minus 1.5 squared, and I get my apothem squared is 13.1164. Now I'm going to take that square root. So my apothem is 3.62. My perimeter is 24. Now I just plug them into the correct formula. Make sure you have the right formula. I keep saying I look on my formula sheet because that's what I'm supposed to do. And again, because it's area, it is square units. I know I rushed to make this, so if you have any questions, feel free to email me or to contact me in any way you can, or ask me in class. Pretty much that's everything that's on the test. It's just formulas and knowing your formula sheet, knowing you're going to have a sector area problem. You're going to have a composite figure problem, which puts them both together for surface area as well as for volume. Your formula sheet is a very comprehensive review.